In this experiment, we were trying to learn more about exponential decay. We did this by setting up a calculator to record the heat of water over time. We got some hot water and opened the calculator with an app that records the temperature over time. We waited for 45 minutes and found the results. We then put the data into Desmos and analyzed it. We'll start off with the initial condition, which is shown in the table here, the graph here, and the equation here. The initial condition is the starting point, otherwise known as the y-intercept. It is 89.983 degrees Celsius. That was the temperature that the water was when we first put the probe in. Next, we will move on to the rate of change. In the graph, you can see that the points are getting closer and closer over time. You may also be able to see that the line is getting more flat over time. Next, we will move on to the equation, here. The rate of change is exponential decay because it is below 1. So over time, it will keep on getting smaller and smaller, never bigger. Finally, we will move on to the table. Now, let's look at the first 5 minutes. This shows the rate of change because after the first 5 minutes, it goes down by 13 degrees. But now, if you look at 36th minute to the 41st minute, you can see that it only went down by 3 degrees Celsius. This is significant because, as the equation shows, over time, it will just keep on getting smaller and smaller. What did we learn out of this? Well, it wasn't only exponential decay that we learned about. We found a real-life sample that taught us about rate of change in a whole. Next, we also learned about initial condition, and it helped us understand how initial condition is tied with rate of change.